Good morning, everyone. I am Tanisha Tyagi from Eshan Publishing, and it's my pleasure to welcome you all to day two of the fourth edition of the Mathematics Summit. Yesterday, we explored some insightful sessions on using technology to enrich the learning experience. Today, we begin with a theme that is deeply connected to the ASER 2024 findings, which not only highlighted learning gaps in foundational numeracy, but also underscored the growing importance of addressing social emotional learnings in schools. Our first session of the day is titled Math Without Fear Breaking the Anxiety Cycle. We are delighted to introduce our speaker, Ms. Alex, a passionate mathematics educator and founder of mathsplay.org. With over 15 years of experience, Alex draws on her own journey from being a math anxious student to an enthusiastic teacher, fueling her mission to ensure that mathematics experiences are accessible, joyful, and empowering. Through mathsplay.org, she champions playful, hands on, and visual approaches that transform the school math experience. Her work inspires learners and educators worldwide to see mathematics not just as facts and procedures, but as creativity, connection, and confidence. And here's something to look forward to. Our exciting quiz will be held today at 4 p.m. after the final session. Winners stand a chance to win Amazon vouchers worth up to rupees 48,000. So don't miss it. It's a fun way to test your learning from the summit and to celebrate the journey together. But before we begin, here are a few important housekeeping notes. Participants will be muted throughout the session. Please ensure you have a pen and paper to note the important information. The chat box will be enabled during the Q&A round and as requested by the speaker. To receive your e-certificates, please complete the feedback form that will be emailed to you on Monday. Be sure to participate in the quiz today after the final session. We'll share the quiz link there. Now, without further delay, let's warmly welcome Miss Alex to lead us into this important conversation. Alex, the floor is yours.
Thank you. Just get my screen up.
Sure.
All right. Well, thank you for having me and for that really lovely introduction. Before I dive into this really important topic, I'd like to invite everyone to engage in a little bit of number play. Start with play is part of the philosophy that I've developed through the last 5 to 8 years of really researching playful and inclusive and empowering ways of engaging in mathematics with students. So this idea of start with play, I invite you, wherever you are tuning in now, if you've got a bit of paper or if you think you can follow along mentally, please do. I'm going to ask you to choose any whole number between 1 and 10. So lock that one in, write it down if you like. Now take that number and add 2 to it. So make sure you've got that new number. So it's your original number plus 2. Hold that number in your mind or write it down. Now multiply that result by 2. So you should have another new number now. Now take away 2 from that new number. And lastly, divide by 2 or halve the latest number that you've got. Now I'm just going to give you a little bit of thinking and checking time to go through that again. Remember your original number, add 2 to that number, double it or multiply it by 2, then subtract 2 and then divide by 2 or halve that number. And now make sure you've got the same number, or this is your chance to check. And now subtract your original number. And I'm just going to hold, I've got a number 1 here. And I'm hoping that you ended up with the number 1. And now you can enjoy pondering why your answer is 1. Now, if we were in a room together, we'd have different people who had different starting numbers. And so here's where there's that spark of curiosity, like how is that possible that we all ended up with one, even though we all started with a different number, or, among us, we've started with different numbers. And so now we have the opportunity, if we like, to think about, well, what's happening here? Do we want to explore a little bit further? What if we made a table and tracked a few consecutive numbers? Say we started with 1, 2, 3, 4, and 5 as our starting numbers, and we had the steps down the side, and we could make a table and see what we can discover, if we can notice any patterns. So if we'd started with 1, we would add 2 to get 3. Then we would double it to get 6. Take 2 away to get 4. Halve it to get 2. And take away the original number of 1 to get 1. And we could do that collaboratively and build up this table. And so I just wanted to start with that little invitation to start with play and curiosity. And I'm hoping that through this session, you'll see other examples where there is a playfulness and a spark of curiosity in the maths examples that we're sharing. I wanted to make a couple of important notes about where I'm coming from in this session. So I have a primary teaching background, and you heard a little bit about my experience. I'm not a psychologist. I am going to be talking a little bit about maths anxiety and drawing on important resources that have been written by researchers and are drawing on educational psychology. My experience is that I started as an integration aide. So I started as a teacher's assistant, and I really enjoyed supporting students who were struggling in certain ways and really building up their confidence through targeted intervention and general positive and empowering language in the classroom. I worked as a classroom teacher in the government sector here in Melbourne. I've since then worked in various research and development roles, and I do identify as a formerly maths anxious student and adult myself. It wasn't until I was teaching, and I was probably about 7 to 8 years into teaching, that I stumbled upon a classroom where things were done a bit differently. And that's where my journey into playful mathematics really began. And I became a little bit obsessed, to be honest. One more important note that I want to make just around the language. Occasionally when I'm presenting or in conversations, I'm introduced as someone who makes math playful or makes math fun. And it's often, you often can see sometimes with games and other things, it might be that this language is, make maths fun with this product, for example. But I think it's really important to stop and reflect, because it is the underpinning idea behind a lot of the sessions I'm sure that you're attending, that it's not about making maths fun, because mathematics is, and you don't have to look far to find a mathematician who will argue this point, mathematics is innately playful and it is innately fun, given the opportunity to experience it in a certain way. And so I would just like to flag this point of language where it's not that we're making maths fun when we're engaging in these discussions, but we're exploring ways of allowing it to be the playful discipline that it is. We're allowing it to be the magical and empowering discipline that everyone can enjoy. And you don't have to go far, as I mentioned, to find mathematicians who are really advocating for a deeper understanding of mathematics and mathematical success and what that really looks like, and the true nature of mathematical work. If you're interested in wider reading, and you can access libraries or you can access books through your workplace, Eugenia Cheng may be of interest. She's written many books, probably more in the realm of secondary college relevance. But if you're interested generally as an adult, I recommend these. There's also Stephen Strogatz. I've only read Infinite Powers and I found it very empowering as someone who really struggled through those senior secondary years. You may have come across ucubed.org or Professor Jo Bowler, a professor of maths education who's really got a wide influence globally. She's written and co-written any number of books, and including ones that are specific to year levels right through from early primary school up to secondary. And another one is Paul Lockhart. And I will say that I have only read arithmetic and a little bit of measurement, but again, I would say the arithmetic is excellent and great for primary and secondary schools reading. There is a free essay online called A Mathematician's Lament, which really touches on this global problem that we have around how maths is represented and experienced in schools. I highly recommend this, even if just reading the first couple of pages. I'm just going to read the opening paragraph for you now, just to give you a little idea of this, the taste behind here. So, a musician wakes from a terrible nightmare. In his dream, he finds himself in a society where music education has been made mandatory. We are helping our students become more competitive in an increasingly sound-filled world. Educators, school systems, and the state are put in charge of this vital project. Studies are commissioned, committees are formed, and decisions are made, all without the advice or participation of a single working musician or composer. And so hopefully you're getting the sense that this is touching on the lack of mathematician input into the school experience of mathematics. And if you keep reading, you'll get to really enjoy that perspective on, well, hang on, what is it about mathematics that's so different and so painfully experienced and narrowly experienced compared to other disciplines like a lot of the arts? And, you know, mathematics is an art in itself, and it is so full of creativity, and creativity along with other traits, but creativity being the big piece that is really missing in the school experience for so many people. So I highly recommend you can just Google A Mathematician's Lament if you would like to read the rest of that essay. So focusing in now on today's topic, maths anxiety. And I'm drawing on a few resources. I've got a book here, which is Maths Anxiety Solving the Equation. It is full of research from around the world. And I just wanted to take a moment to sort of try and define maths anxiety. It can be difficult to define, and it can vary across individuals and contexts. But maths anxiety is related to the area of the brain associated with threat detection and pain itself. This shows how real maths anxiety can be and how maths anxious individuals' brains can respond to maths as though it is a physically painful experience. And I remember another piece of research that I read from the ucube.org website, or another article, which talked about how the same part of our brain lights up as the part of the brain when we're scared of snakes or spiders. The same part of the brain lights up in people who are scared of numbers or have maths anxiety when they are faced with a maths problem. So it's pretty compelling stuff. And it is very much a reality. It's a real thing, maths anxiety, in terms of what's happening in our brain, and then the sorts of physiological and other emotional responses that it can elicit. So what are some symptoms, causes, and companions of maths anxiety? Just to locate us around what this issue is. Well, symptoms, they can be physiological and cognitive. Physiological, like sweating, shaking, tremors. These can be experienced when anticipating or participating in maths. So it can be like on the way to maths class, or the dread of knowing that maths is coming up, or while actually in that experience. Some causes: enduring negative beliefs and thinking patterns around maths potential, and of course influenced by experiences struggling with maths and by parents, teachers, peers, and society. And companions of maths anxiety include poor maths confidence, disengagement from mathematics, and really importantly, some valuing of mathematics. So this is the thing where, we get anxious about things when we care about them. So this is a really important point, that we do value it in some way. If we didn't value mathematics at all, then we'd probably be more apathetic, and it wouldn't so much be maths anxiety. We might be disengaged, but we wouldn't necessarily experience maths anxiety. There needs to be some level of care there. Now, this is just to give a little bit of an idea of what's actually going on. Completing a maths task, experiencing symptoms of maths anxiety, these can begin with invasive negative thoughts. I'm never going to be able to understand this. And then ruminating on those thoughts. And ultimately, while ruminating on thoughts and having low confidence while trying to complete a maths task leads to this working memory overload and more like errors being made, freezing, blanking, panic sort of setting in some instances. Anxiety, panic. Now here's an important note that I came across in the book that I just wanted to raise before we get into some strategies and activities. It's important not to overlook students who do not have low mathematical attainment, as it is not guaranteed to be an indication of maths anxiety. And just a hint, is one of our questions from this session is speaks to this point. It's also important not to assume that a student with low attainment is maths anxious, yet acknowledging that low attainment can often be a factor within the experience of maths anxiety provides teacher with a valuable insight that can be used to identify and support maths anxious individuals in the classroom. And we should also, of course, be mindful of students in the middle range of maths attainment and anxiety who are not in obvious need of support, but they run the risk of experiencing a downward trajectory if they develop a negative experience of mathematics through various factors. So one of the key takeaways here being that you don't have to have low scores or low achievement in mathematics to experience maths anxiety. So we really need to be aware that it can be experienced by anyone in the classroom, regardless of their mathematical background and achievement to date. So a few what's and who's that can influence maths anxiety. And these are just a bit of a list that I'm hoping that through the activities and strategies, you can sort of see how they play together. So damaging myths about mathematical success, things like, speed is really important. Maths is a subject of abstract concepts and correct answers. If you are slow in answering a question, then you're not very good at maths. These sorts of damaging myths. Test scores and other performance-focused feedback can create a sense of anxiety when the maths experience is distilled down to being about, what score did I get or what grades did I get, rather than what is the actual maths that we're enjoying and exploring and learning together. Being humiliated in front of peers for low achievement or for being wrong. So I don't know how many of you grew up experiencing this or have seen this in action, but mathematics seems to traditionally have a culture of, we really want to move on here. We really want the correct answers. And there's sort of a sense of praise and sometimes, unfortunately, ridicule in the classroom around this. And it doesn't even necessarily need to be really overt. Sometimes it's the matter of a tiny look like, can send messages to students that they're failing and that they are not bringing the value that as a class or as a culture or as a group is that we're waiting for. Timed mathematical situations. So again, that point about speed being really important, that can be stressful and can elicit anxiety in students. Specific mathematical content, depending on the year level that you work in, it might be place value, it might be something to do with multiplication or division, it might be fractions, it might be something else, but often there is specific mathematical content that can be tricky, and if it's not taught in a really in a certain way, or if not enough time is spent, then it can cause stress and anxiety. And this is actually this is not in order of importance. This last one is a really big one. And attitudes and behaviors of parents, peers, siblings, and teachers. You know, we are social creatures. We're very influenced by the people around us. And this case study points to some research that was conducted in India with 595 students between the ages of 10 and 15 years old. Along with their parents, and with just one parent measured per student, they found that parents' maths anxiety significantly predicted their child's maths anxiety and their attitudes toward maths. Similarly, parents' attitudes towards maths significantly predicted children's maths attitudes and maths anxiety. And this is not unique to India. It's a similar case in where I am here in Australia as well. So very much a global influence. So moving more into a few solutions now and some specific maths examples in a minute, I came across the growth zone model, which I really like. It's more specific to maths anxiety than anything I've come across before. But the growth zone model can be introduced to learners, teachers, and parents and carers. So everyone involved, support staff in the maths context, to help distinguish between productive nervousness and disabling panic, and as a way to really help communicate these emotions without feeling silly or stupid. So I like this idea of having a visual. I think it also demonstrates that, you know, the green comfort area, it might be where we are getting most, if not everything, correct, or we're finding it really easy. We're not necessarily learning a great deal when we're in that space. So if we are getting 100% or all those sorts of things, well, what does that say about, you know, maybe we need to be a bit more challenged? And are we in that growth zone? Can we start with comfort as warming up our maths brains, and then make sure that we move into that growth zone regularly, so that we are struggling with problems, so that struggling with mathematics becomes important. We develop mathematical resilience, so that everyone experiences aha moments and time to wrestle with problems, and making sure that we're aware as a community that there is also this space to be out of our depth and to experience maths anxiety, and really just having developing a normal culture around discussing and experiencing that, and kind of being in this together and supporting each other. So I really like that as a tool, and you can learn more about that. I'm going to provide a copy of these slides at the end of the session. So there's a link there that you can read more about that and other strategies from a toolkit for teachers and learners that in the research space. So what are some things that can be done to alleviate maths anxiety? So in addition to that growth zone model, well, a big one is going to be challenging and correcting those damaging myths about mathematical success. And I'll point to a few resources in a minute. Reevaluate how timed mathematical situations and test scores are used. Why are we using these? Are they helpful? Are they hindrance? Are they causing problems? What can we do instead? Activating student ownership through tasks, options, and flexibility. Some examples coming up in a minute. Normalizing mistakes, imperfection, and challenge. So again, pointing to that, well, if we're getting correct answers all the time, you know, how much more deeper can we go to really extend ourselves as learners? Lead a culture of curiosity, kindness, and collaboration with regard to mathematics. I think for many people, the maths experience can be quite solitary. And so really building a collaborative culture and creating space for students to be talking with each other and learning with and from each other as alongside the teacher is really important. And keeping families in the loop about our cultural goals and the ways that they can support. So now that we've just got a little bit of that topic, the big topic under our belt, I'd just like to share 3 big ideas for action. And the first is really that building a bias-free culture of collaboration, inspiration, and inclusion. and just a few little strategies, practical things that you can do or places to go where you can get some resources. So the first strategy under this big idea is to use mindset lessons that have been designed for this very thing, busting myths, building positive and inclusive classroom cultures. And one place you can go and find some really powerful resources is ucubed.org. And this brand new video, it's just a minute long, so I will play it. So you can have a break from my voice and hear the voice of Joe Bowler, who's doing so much work in this space and has a myriad of videos and resources. Let's think about some different ways to learn mathematics.
Did you know there's more than one way to learn maths? One way is with step-by-step rules. Learning this way might work for a while, but it often leads to a fragile understanding. Then there's a deeper way, through investigation and reasoning. Exploring why things work. And learning this way builds number sense and flexible thinking, and it sets you up for greater success in the long run. Some people think that students with learning differences can only learn through small steps, but that's a form of deficit thinking, because they too deserve to experience the beauty and the depth of mathematical concepts and connections.
What I liked particularly about this video is that it very quickly, with the beautiful illustrations, speaks to the why and the how of mathematics, which is often discussed as the pieces that's missing, rather than just the what, which is, what's the correct answer, incorrect, correct. If you go to ucubed, you may already be aware, it's quite a well-known and established website. It's been around for a number of years now. ucubed, they have a week of inspirational math, which has a lot of other little videos that teach around these norms and the positive experience of mathematics, as well as lots of actual maths activities, where you're practicing addition, multiplication, and other concepts through what they describe as rich tasks. And so that's a place that you can go for lots of different resources. Another similar strategy, so in addition to using mindset lessons, is to participate in global celebrations through positive, playful, and powerful activities. And perhaps you've heard of the International Day of Mathematics, but it's celebrated every year on the 14th of March. And each year there is a different theme. So this year the theme was mathematics, art, and creativity. Last year the theme was playing with mathematics. Next year the theme will be mathematics and hope. And it's another place that you can go for some really rich tasks that give students a little bit of a different experience to the everyday sort of textbook curriculum that they're engaging in, and allows them more a window and an experience with lots of really hands-on mathematics for different year levels. It's mostly targeted at probably upper primary and secondary, but there are a few activities for younger learners in there as well. And each year they have a global challenge, so a creative challenge. This year it was to create or submit images of mathematics that you can touch. So individuals and groups submitted lots of photos which you can explore and use to spark some discussion. But I'm not sure what the challenge is going to be next year, but each year they have a different creative challenge. One year it was posters, another year it was add maths art to a particular space. So there's lots of ways that we can give students other experiences of mathematics which is beyond the textbook, and I think that's really important. Another strategy for this first key idea, is to provide space for sensitivity. So this is something that I've learned to do in my everyday practice, and it's just been absolutely transformative, I have to say. Asking open-ended questions and then funneling in and giving the kids the space to get stuck and figure out using mathematical reasoning and agree on a correct answer. I'm just going to play a little clip here where you can hear a couple of junior primary school students engaged in a maths talk. So they've just had a little bit of a look at this train, this dot number train, and done a little bit of noticing and wondering about it. And now we've funneled in to figure out exactly how many dots there are and how can they be absolutely sure about their answer. Great. Now, I'd like you to take a moment to count how many dots there are all together. So have a think about how many there are.
It's 14. 11, 12, 14, 15, 15.
So we've got 14 or 15?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15.
All right.
I think we're counting a bit wonky because 4, there's 2, 2, 4, 10. So there's 10 here and 4.
Yeah.
Oh, maybe 14. Yes, 14.
Now, Axton, you got 14 before, so how did you see it as 14 originally?
Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 14, 15. I'm just getting confused. But that's 4, then but that's 4, then how does that make? It's 14 because 10 plus 4, so 10. 10 makes the teens and 4 more. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. There's 15.
11, 12, 13.
13,
Yeah.
that's what we were missing.
Yes, that's
13,
right.
14.
Yes. I knew you knew it. You were just getting a bit confused with the number order. Now, no. What I really liked about this interaction was other students were working independently on various maths activities, either in pairs or on their own. And I was able to call over a couple of kids at a time and really just give them that space in a small group to engage in some sense making and discussion before running number talks with the whole class. So just getting them used to actually struggling, defending an answer, figuring out, which answer is correct, and an experience where it was normal to have a wrong answer, but that through discussion and through some wrestling, we could come to an agreement on what the correct answer was. So that's an example with a young class. This is an example of, again, you can see in the top right-hand corner, lots of different answers have been collected here. So the question was posed to the class, how many blue dots are on these 10 frames and how do we know? Like, come up with your favorite way of knowing your answer. And they were given think time. And we collected the different answers before we shared different strategies. And as you can see, all of the different strategies that we've got there, they're very, very different, but we all ended up with the same answer in the end. And I think this was probably a little bit tricky for the class, this particular one. We had lots of different answers and probably not enough skills developed. But what I love about number talks is it creates that space to think in different ways, come up with our own solutions, and then listen to each other's solutions and have questions or make connections between our different ways of knowing. In older classrooms, number talks can get more into the abstract. These are some examples from senior primary, and they're focused on division. And as you can see, we've got examples of skip counting by 3 to get up to 18 and counting how many times 3 goes into 18. We've got other strategies that think about 18 in terms of its parts. So that middle one at the top there, if we split 18 into 9 and 9, because we know that 3 times 3 is 9, then we can get an answer that way. And so we have this experience of sharing different ways of knowing and agreeing that there is often more than one way that is efficient. So that not all ways are particularly efficient, but there is always going to be more than one way. And there is not just one efficient way of approaching arithmetic problems. What I love about this is that we all come together without pencil and paper. So we're really pushing on our mental understanding of number and applying things like place value and taking numbers apart and putting them back together and developing number flexibility, so that ultimately, if we're doing these kinds of discussions regularly, and they usually only take 5 to 10 minutes, then over time we're really developing number sense and a sense of confidence. And I would say that number talks has probably been the most powerful thing in terms of students who were reluctant coming up and saying, are we doing a number talk today? And really seeing a shift in mindset and a building of confidence. One other thing I would say about this use of number talks, so coming together as a class, having a number problem and collecting different ways of solving it, is that it really needs to be invitational. So I used to use accountability sticks, where you have, I'm not sure if this is used where you are, but it was quite common in certain settings where I was teaching to have every student's name on a stick in a cup and just pull out and say, okay, this person or these people are going to share their solutions today. That's something that I've stopped, because at one point I realized that actually this is not productive in terms of making sure that everyone's feeling accountable and taking part, but also it is a risk for causing maths anxiety or panic, or so I didn't want it to be a risk factor. So keeping number talks invitational, and having, if you're able, having small group number talks with 2 or 3 kids is a really powerful way of really shifting and building that confidence and seeing a change in students' willingness to participate in these discussions. So just with those strategies that we've looked at, using mindset lessons, engaging or participating in some of those global days like International Day of Maths, and making sure that there is regular opportunities for students to verbalise their thinking and struggle and reason aloud and have those collaborative opportunities. I wonder what you saw from this list. So this is the list we had up before about what can be done to help prevent and alleviate maths anxiety. I'm just going to give you a moment to have a look through which of these things did you see applying to those examples. You can make a note to yourself. If you have something that you'd like to pop in the chat, feel free. But this is really just a chance for you to stop and reflect. So for me, challenging and correcting damaging myths about mathematical success through those mindset lessons sort of jumps out. And normalizing mathematical mistakes using those discussions about, what answers did we get? And actually expecting the group to come up with more than one answer so that we can then use reasoning to check ourselves. The second big idea that I wanted to bring up is about using and celebrating visual mathematics. And I'm just citing a particular website that has a lot of research around this and the importance of helping students see mathematics in the world around them. It's called haveyougotmathseyes.com, and there's lots of teacher resources and classroom resources that might be interesting and useful for you. But one of the strategies for using and celebrating visual mathematics is to use mathematical scenes and photos if you can, or if you don't have access to the technology to show photos, going for walks around your space, or getting students to maybe draw a scene from home or whatever, but just really engaging students in the environment around them. And the second part of that is, with that visual, begin with an open-ended question and then funnel into a specific mathematical focus. And I've just got a couple of examples here. So if you had a photo or you had the physical object of this in your classroom, starting with very open-ended question pair. So what do you notice? What do you wonder? And I'm just going to give you a moment to engage in that question. Feel free to type in the chat if you like, or just make a thought to yourself. What do you notice? What do you wonder? All right. And what we would normally do as a group is the students would then maybe turn and talk to the person next to them about what they notice and what they wonder. Maybe we would have a couple of ideas shared to the class. It wouldn't really take too long, but it's important that they've had a chance to have a look, have a think, and engage in some sort of sharing. And then we would move to a more specific focus where we're getting into our mathematical reasoning again. How many sticks of chalk are there altogether? And importantly, what's your favourite way of knowing? So the answer is an important part of this, but the most important part, like in a number talk, is what's your favourite way of knowing? And we would have a little bit of time to share 2 or 3 different strategies. And it may well be that you've got someone who contributes skip counting, which is a really fair and valid strategy. It's part of our developmental way of learning multiplication and multiplicative thinking. But because we've opened it up to the floor and have different brains contributing to this discussion, it may well be quite likely that someone would notice that they can sort of see 2 halves and that they can think of it as 5 and 5 times 5 plus 5 times 5. And so we have got an opportunity here to tap into that commutative nature of multiplication, and we're using the correct arithmetic and symbols to express the things that we've noticed and in terms of getting our answer. I'm going to share one of my favorite visuals now, a little bit more complicated. So again, what do you notice and what do you wonder? And whenever I run this, of course, there's stuff around shape. We have sometimes someone knows about triangular numbers or square numbers. You can see that we've got a 4 by 4 grid there. So 4 times 4 being 16. But just a general, what do you notice? What do you wonder? Having that open in it, so everyone can participate. Even if you're unable to count, you can participate in this discussion through our first very open-ended question, and then we're going to funnel in how many towels altogether. Importantly, what's your favourite way of knowing? And again, we've got this visual artifact that we can use arithmetic to explain or to describe. And it may well be that, someone's seen that, well, they know that 2 times 6 is 12, and they've used that knowledge to figure out 4 times 6 because perhaps that wasn't a fact that was particularly ready for them. And they thought, well, I know that it's going to be double 2 times 6. So we're having these discussions about the relationships between different. What's 2? We're going to double that to get the second shelf, and then we can double it again to get the whole. Now, this is interesting though, because how are we going to know for sure what the answer to 2 times 48 is? So this is where we might get a little bit stuck, and we might share a couple of different strategies depending on the level that we're operating at. How could we figure out 2 times 48 so that we're absolutely sure about the answer? Because it's sort of a little bit sticky. There's going to be if we were doing it in a vertical algorithm, there'd be some carrying or something. It feels like a little bit of a tricky one. So what's one way? Well, we could break up the 48 into 40 and 8. This is demonstrating an understanding of multiplication and how it works. And then we could add those numbers together. We could make it 2 times 50. That's very easy. I know that one. That's 100. And then we could take away the 2 2s that we added on there. And so we're thinking about multiplication in different ways, and we're bringing in addition and subtraction and using it in the pursuit of solving a little bit more of a tricky problem. So I'd just like to cite that website, Have You Got Math Slides? There's lots of fantastic photos there that you can use and other resources as well. But on this topic of maths visuals, moving from the photos and the real scenes to some more simply mathematical visuals, I just want to acknowledge that we can start with a visual, like we started with the photos. We started with a visual and we did some explaining around it and applying arithmetic. We can do that with mathematical visuals. We can also end with visuals when we start with an abstract problem. So I'm just going to show you that now. So for instance, we could have, how many dots do you see? More importantly, how do you know? So you can hear a little bit of this repetitive, like more importantly, what's the reasoning? How can we be so sure? How can we be sure that we've got a precise answer? And we could have different ways of breaking up our array to help us with those calculations. So really getting a sense of, it's not so much about like, I've got to know what 7 times 4 is. I've just got to remember, I've got to go through my times table to get that. This is more looking at, well, what is 7 times 4? It's 5 times 4 and 2 times 4. Breaking it up and putting it back together, a point of number flexibility, which is just so important. But for many of us, I know for me, I didn't really have the opportunity to experience number flexibility and creativity when solving arithmetic problems until I was an adult. And I kind of was a little bit sad that I missed out on that growing up. So again, we've got different ways of thinking about what we see and applying the kinds of arithmetic that we're working to master in meaningful ways to describe what we see. So it might be a matter of doing some skip counting. It might be, and then a little bit of addition. If you're interested in this topic of mental play with dots, I like to call it, there is a blog post that you can read and have a look at some other examples. But I wanted to move now to this other side of the visual mathematics, where we will end with visuals to explain, make sense of, and or solve problems. So let's have a look at a wonderful operating with fractions problem. This is one which I used with a couple of year 8 kids and some year 6 kids not too long ago. And as predicted, we had the need to use visual models to really check our answers, because our answers were incorrect. So there are different visual models, but one of my favorite ones for this problem is really just, an area model like this. Let's visualize what 3/4 is and think about what's happening when we're adding them together. So again, we're really tapping into number flexibility and giving kids opportunities to think about this, and really explicit teaching around the importance of these visual models is really powerful, because, as you can see, we can move 1/4 over. And then visually, what will we have? Yeah, we'll have 1.5. And so a common mistake for a question like this, by just trying to remember rote-learnt formulas, is to come up with 6/8. And this happened with both the senior primary group and the year 8 group that I worked with. This was the common mistake that came out. And then the beautiful thing about the year 8s too was that they beautifully simplified the 6/8 into 3/4. So they were able to simplify really beautifully, but there were no alarm bells going off that 3/4 plus 3/4 equaled 3/4, and that made sense. So we're really trying to go develop a habit of using visuals or imagining visuals, really thinking about, what do these numbers mean, and therefore, is our answer reasonable? So that reasonableness of answers. So in this example, as you can see, we've ended with a visual model to help us. We've started with the abstract question, and we've brought in some visuals to help us with our mathematical reasoning. And I'm just going to finish this section by pointing to some neuroscience I think I accessed this through the U-Cubed website. There's lots of great research and articles on that website. It's been a godsend. But this, I found this to be really compelling. When we work on mathematics, brain activity is spread out across a widely distributed network, which includes 2 visual pathways. Neuroimaging has shown that even when people work on a number calculation, such as 12 times 24 with symbolic digits, 12 and 25, our mathematical thinking is grounded in visual processing. So when you learn that your maths brain has these big visual centers, it really speaks to how important it is that we have the opportunity to experience it visually in a regular and and across the maths curriculum. I think one of the points that someone made along the line that I often think is that there's barely any maths in school that you cannot visualize, and so that feels really important. So coming back to that again, so we've just got to have two out of three key ideas on the maths using and celebrating visual mathematics. Which of these ideas from the list really stand out to you? I won't spend too long, but maybe just have a little think of, okay, which of these dot points really stands out in this point? All right, I realise we're a bit strapped for time, so I'm just going to do my best to go through the third one without being too quick and leaving you with lots of resources. So activate student ownership through task flexibility. Often mathematics is experienced as, okay, we're doing page 10, and we're all doing this and we're all going to hopefully get the same answers and get things correct. But actually opening up tasks or providing opportunities where students have ownership and they get to make some mathematical choices about how they proceed, not only helps you to differentiate to lots of different abilities in the class, but it hands over some power to students. So one of the ways I love to do this is through arithmetic games where students make choices. And these are like pencil and paper games. And I'm not going to spend too long here, but you can go to a blog post that I put together of favorite dice games, which are appropriate for, children sort of as young as year 1 up to senior primary, lower secondary. I mean, I would say they're really for all ages, but you can have and explore different ways where students are trying to reach an end point, but they get to make choices about how they get to make mathematical choices. So for instance, in double or half, when we roll a dice, they decide they're either going to double their number or they're going to halve their number and add it to the running total because they don't want to go past the target number. They want to get as close as they can. So these kinds of games where there's like a target and it means that you think about number proportions and you make choices and you think about chance and probability as well in some cases too. The second strategy is really the really big one, is use tasks with different solutions. So for instance, we might start by looking at some rectangles and non-rectangles as a class. Like, what do we notice? What do we wonder? How could we think about these numbers using these visuals using arithmetic to describe them? And then having an explorer's menu where the students decide, okay, I'm going to either work with 12 or 24, and I'm going to explore, how many possibilities, how many ways to make a 12 square rectangle or a 24 square rectangle. And this is a task that can be used with really young children, and they can be recording their work right through to senior primary and secondary and different ways. So these are really so open-ended that they really span many grade levels. And by having those choices about what number to work on, but having some inbuilt connections. So of course, there's connections between 12 and 24. And it might be that you have just, a few questions that they can continue to explore once they finish. So for instance, how many possible ways can you make a rectangle with 24? What about 28? What about any number from 20 to 100? So really, this idea that maths is never done, that the investigation is never done, something that I felt more equipped to do with these open-ended tasks is avoid rewarding early finishes, which is something that I want to do to create an inclusive environment where everyone is participating and no one's being rewarded for being fast or finishing quickly. So opening up mathematics so that it can continue and so that everyone can engage in different ways. A favourite activity that was shared by Professor Amy Albrecht here for the International Day of Maths, called Quarter the Cross. I think this was a really beautiful visual example of a task with lots of different visual solutions. So you've got to quarter the cross, you've got to have a quarter in a certain one quarter in one color and color code, and all these different solutions, kind of creating beautiful artworks in a way in some instances. And so just being aware that there are lots of open-ended tasks around and that they do link to our curriculum. So fractions, multiplication, area, perimeter, those sorts of things. You don't have to look too far, but really thinking about how we can open it up so that students are having some choices about how their solution looks, where their solution starts, etc. So coming back to this idea, what can be done to help alleviate maths anxiety? So in the open-ended tasks where students get to make choices in games, where they get to make choices about how they proceed with play, what of these ideas stand out for you? So that's just three big ideas for action. It's very difficult to sort of pack so much in. It's such an important topic, this topic of maths anxiety, and we haven't spent too much time thinking about how to talking about the homeschool connection. But I really want to point out that that homeschool connection is really important. I'm not sure how it looks where you are. Here, there are different ways to get families involved through open days, through little conversation starters that we might send home, getting the kids talking about how they're experiencing maths a bit differently, or the goals that we have as a whole class to really make sure that everyone feels included and that we're experiencing maths more about the what and the why, so that we can be confident and precise about our answers and less worried about being really fast and getting right answers all the time. I thought I did want to give you a chance to, so I can take a breath, have a think about, as a result of this session, what is something that you plan to continue doing? So something you're already doing that has been affirmed or supported here. Something that you would like to start doing, so something that's new and which aligns to your goals and practice, and something that you might stop doing because you've been doing something that you'd like to let go of or rethink or replace as a result of this session. So you might have an answer for one or all of these, but I'd love for you to take a moment, either think about that for yourself, feel free to pop it in the chat for the benefit of others, and I'll just give you a minute or two, and then I think we'll be coming to the end of this session.
Participants, if you have any query or questions, please drop your queries in the chat box.
If anyone would like a copy of the slides, you can email me and I'll get them to you as soon as possible. If you'd like to connect and follow along with a few maths play resources, you're more than welcome to jump on Instagram and do that as well. So thank you very much for having me.
I can see the positive feedbacks for you only in the chat box. No questions so far. Yeah.
No problem.
Participants, we are dropping in the session link if you want to rewatch it. Yeah, I guess there are no more questions only. Thank you. Perfect.
Thank you very much.
Thank you so much, Alex, for your enlightening presentation on Math Without Fear, Breaking the Anxiety Cycle. You have brilliantly highlighted several key takeaways, identifying and addressing the root cause of math anxiety in students, promoting a growth mindset to build resilience and confidence, and more. I'm sure today's session has given all of us practical strategies to help learners see mathematics accessible and empowering. Thank you all to all our participants for joining us this morning. We hope you found the session both informative and inspiring. A quick reminder for all the participants, our next session, the Math Mentor, Upskilling Teachers for Impact with Mr. Shravan SK, will begin at 12 noon IST today. We look forward to seeing you there. Stay tuned for more sessions packed with insightful discussions on reimagining mathematics education. And of course, don't forget today we have our big quiz with Amazon vouchers worth up to rupees 48,000 up for grabs. And an important update for all the participants, the 3 to 4 p.m. session has been cancelled due to unavoidable circumstances. We now have only 2 sessions remaining in the summit today, one at 12 noon and another at 4 p.m. today, where we will also take the quiz. So, everyone is kindly requested to make a note of it. See you shortly at 12 p.m. Thank you, everyone. Thank you so much, Alex.